Hi, this is Mrs. Doris. This is lesson 9-5. It's entitled Completing the Square. Our objective in this lesson is that you will find the solutions to a quadratic equation by completing the square. This is another way we have. We basically have three ways of solving a quadratic equation. In the previous lesson, it was by factoring a quadratic equation, but not all quadratic equations can be factored. So the other two methods, we're going to do one today, and I'm going to go ahead and cross this out because it is called completing the square. And then tomorrow's lesson, we're going to be using the quadratic formula, which is the last way that we have of finding the solutions. Also recall, finding the solutions means finding the x-intercepts of the graph. It means finding the roots of the equation or the zeros of the function, just to review our vocabulary. All right, for instance, here, this is just a little model. It says model the expression of x squared plus 6x. And of course, the blue square is our x squared. Each of our green rectangles is a 1 by x. So here's one x, there's an x, another x, an x, an x, an x. And of course the area of each of those is 1 times x, or just 1x. So there are 6 of those. So in order to complete the square, which is what we're going to be doing in this lesson, notice that you would need to add 9 little square tiles to complete it. And here's a picture of what that would look like. I have a few more examples. Here's a model of x squared plus 8x. How many squares would it take to complete this square? Well, it would take 16 tiles that would be a 1 by 1 tile. And there they are. All right, and that makes a full square then. Another example, x squared plus 4x, it would take 4 tiles to complete it. And x squared plus 2x, it would only take 1 tile in order to complete it. All right, so to summarize these 4 models, the question is, how do you get from column 1, your expression, to column 2, the number of tiles that you need to complete? Well, what you might notice is between columns 2 and 3, 9 is a perfect square, 16 is a perfect square, 4 is a perfect square, and 1 is a perfect square. And this is how we know that. We know that 9 is 3 squared, 16 is 4 squared, 4 is 2 squared, and 1 could also be written as 1 squared. Now, so how do we get that? Well, let's go back and take a look from here over to our b. This would be our ax squared plus bx term. So we want to look at the b. And what I hope that you notice is that here we have a 6, and 3 would be half of 6. And then we square the 3. Here we have an 8. Half of 8 is 4, and then we square it. Here we have 4. Half of 4 is 2, and then we square it. Half of 2 is 1, and then we square it. And that's the little formula that we're going to use in today's lesson. All right, so to fill in your notes, you can change the expression x squared plus bx into a perfect square trinomial by dividing b by 2 and squaring it. In other words, you take b divided by 2, notice in the parentheses here, and square that number. Then you add it on. This is called completing the square. The equation y equals x minus h in parentheses taken to the second power plus k represents a parabola with a vertex at hk. This form is called the vertex form of a quadratic equation. Now, this is a formula I'm not going to require you to memorize. We will do an exercise in today's lesson just to introduce it to you, and we'll do a problem, but I'm not going to require you to memorize that formula. Completing the square can be used to solve any quadratic equation where a is equal to 1. To solve any equation where a is not equal to 1, then you have to divide all of the terms by a before you can complete the square. All right, so problem 1. Finding c to complete the square. What is the value of c such that x squared plus 20x plus c is a perfect square trinomial? Well, what we want to do is we want to take b, which is 20. We're going to divide the 20 by 2 and then square it. All right, 20 divided by 2 is 10, and 10 squared would be 100. So if we replace c up here with 100, note that this we could factor, and this is the whole purpose. It's a perfect square, so what we do is we put take the square root of 100 is 10, and we'd have x plus 10 times x plus 10. Or, writing that, we'd have x plus 10 squared. And then we can take the square root of that. So that's going to be our ultimate purpose. All right, problem 2, solving x squared plus bx plus c equals 0. What are the solutions of the equation x squared plus 9x plus 15 equals 0? All right, well, first I want to point out, this is an equation that cannot be factored, and that's why we need other ways of solving it. Notice if I were looking for the factors of 15 that would add up to 9, my only factors of 15 are 1 times 15 and 3 times 5. And neither one of these will give me 9 in the middle. So this is not a factorable equation. So we're going to complete the square. To do that, in this case, what we want to do is we want to remove the 15 to the other side. All right, 15 minus 15 would be 0, and so I have on the right side 0 minus 15 would be negative 15. Now, this is as bad as they get, really, in using completing the square, because b is not an even number. And yet we still want to take, we're going to add on, we're going to take that b, divide it by 2, and square it. All right, and if I add that on to the left-hand side, in order to keep my equation equal, I have to also add that on to the right-hand side. All right, so what I am left with, and the easiest way to do this, is simply to recognize that when I factor this, I'm going to have x plus 9 over 2 quantity squared. All right. If I were to write it out and FOIL it, I would have as my outer term and inner term, I would have 9 over 2x plus 9 over 2x, which would be 18 over 2 times x, which is 9x. And that 9x is exactly what we want because we have 9x in our equation. All right. Now, on the right-hand side, we do need to evaluate this expression. So I have negative 15 plus 9 over 2, if I square it, would give me 81 over 4. And I'm going to write that as a mixed number. It'll be easier to solve. It would be 20 and 1/4, or you may prefer 20.25. Either way. Let's go ahead and I'm going to rewrite this again. And I'll go ahead and change my 9 over 2 to 4.5. And on the right-hand side, I've got 5.25. And I'll go ahead and write it as a decimal. Now we're going to take the square root. All right. On the left-hand side, when we take the square root of a quantity that's squared, we simply end up with x plus 4.5. On the right-hand side, remember, a lot of people forgot on the quiz, you're going to have a positive and a negative, and you'll want to grab your calculator to determine this square root. The square root of 5.25 would be, and we'll have to round it off. Let's do it to the nearest hundredth. It'd be 2.29. All right, now we are ready to solve and find our two solutions. So we have two equations that we have to do. We have to do x plus 4.5 equals a positive 2.29, and we also have to do x plus 4.5 equals a negative 2.29. All right, so subtracting 4.5 from, let me line it up. Okay, I'm going to end up with x equals, and you may prefer using your calculator for this. I'm going to end up with a negative 2.21. All right. Easiest way to do that, of course, is to turn it upside down. All right. Add your 0 up here and then subtract. All right. And then because we are taking a larger number from a smaller number, of course, we have a negative answer. So negative 2.21, and remember that is an approximate figure. And then subtracting 4.5 from each side of the second equation, I end up with negative 6.79. All right, so my two solutions are negative 2.21 and negative 6.79. And remember, if we were graphing this equation, just a quick simple little graph, the two solutions are going to be at negative 2.2, let's say it's about here, and then negative 6 over here. So we know that it would be looking something like this. All right, problem 3. Finding the vertex by completing the square. All right, so it says find the vertex of each, parabola using the method of completing the square. All right, well, remember the first step we want to do is subtract the 10 from each side. So I would have y minus 10 equals x squared plus 4x. Now to complete the square, I want to take my b, in this case it's 4. I want to divide the 4 by 2, and then I want to square that. All right, 4 divided by 2 is 2, and 2 squared is 4. So I'm going to add 4 on to each side, and I also need to add it over here to the left, to make sure that everything stays equal. So let's go ahead and write down what we have. Y minus 10 plus 4 would be y minus 6. On the right hand side, I'm going to go ahead and factor this trinomial, which would factor into x plus 2 squared. And you may prefer simply, in this step right here, taking the 4, dividing it by 2, and showing it this way. And that's up to you, but then it does help you factor it because your two factors are x plus 2 and x plus 2. All right, now we are ready to take, nope, we're not quite ready. We want to find the vertex. Next thing we have to do, now we're going to add the 6 over to the other side. Okay, now go back to your notes. And it may help you to write it in this form. I'm going to take x, I'm going to rename that plus 2 as minus a negative 2 plus 6. And our vertex for this problem, remember, is this is our h and this is our k. So the vertex of the graph of this equation would be at negative 2, 6. All right, I'm going to erase this to make a little room for my next problem. We're going to do this again. Okay. On our problem over here, of course, I want to subtract the 24 and subtract 24 from the y so that I'm left with y minus 24, and I'm going to leave a little space here, equals x squared plus 12x. All right, our b is 12, so we want to take half of that, which would be 6, and we're going to add on 6 squared. So I want to do the same to the left-hand side. I'm going to go ahead and on this side and rename 6 squared as 36. All right, simplifying. Let me move this out of the way for us. Y minus 24 plus 36 would be y plus 12 equals okay, excuse me. I'm looking back and I'm seeing in your notes this is a 3. So we're going to subtract 34. All right, so this should be a 3. And y minus 34 plus 36 would then be y plus 2 equals, and again factoring our perfect square trinomial, it would factor into x plus 6 squared. All right, let's go ahead and subtract the 2 from each side so that we have y equals the quantity x plus 6. And again, it may be helpful, you don't have to do this, but just to put it into the form of the vertex form, I'm going to rename plus 6 as minus a negative 6. Okay. And what we see here, I'll write the vertex up here. Our vertex would be negative 6, negative 2. All right. And again, you may want to rewrite this as plus a negative 2, and that way you can see that truly this negative 2 would be your y coordinate of the vertex. All right, problem 4. You are planting a flower garden consisting of 3 square plots surrounded by a 1-foot border. All right, let's draw a picture. Okay, so we have 3 squares, and they're surrounded by a 1-foot border. All right. The total area of the garden and the border is 150 square feet. What is the side length x of each square plot? All right. Well, our length, notice, would be 3x plus the foot on each end, which would be a total of 2 feet. Our width is going to be x plus the 1 foot on each edge, so x plus 2. So we have the expression 3x plus 2 for our length times x plus 2 for our width is equal to 150 square feet. All right, let's go ahead and multiply this using FOIL. 3x times x is 3x squared. My outer term, 3x times 2 is 6x, plus 2x would be 8x, and 2 times 2 is 4, equals 150. All right, now this is a rather complicated one to complete the square on, but that's what we're going to do. First thing that we're going to do is we'll subtract the 4 from 150. So let's subtract the 4 from 150. That gives us 3x squared plus 8x on the left, and on the right hand side we have 146. Now we cannot complete the square as long as we have this 3. So what we've got to do is to divide everything by 3. It's like dividing the whole left side by 3, and we're dividing the whole right side by 3. All right, now we can get rid of that. We have x squared plus 8 over 3x on the left, and on the right hand side, let's go ahead and evaluate this. 146 divided by 3 would be, let's see, 48 and 2/3. Okay? All right, so completing the square. I want to take my b, which is 8 over 3, and I want to halve that. Half of that would be 8 over 6. That would be taking 8/3 times 1/2. And that would be 8 over 6. And of course we're going to square that to make a perfect square. And so we're going to add the same thing to the right side, 8 over 6 squared. All right. Going ahead and factoring, we would have x plus 8 over 6. Let's go ahead and reduce that. 2 goes into 8 4 times. 2 goes into 6 3 times. So it'd be x plus 4/3, quantity squared. On the right hand side, let's do the same thing over here. This is the same as 4/3 squared. So we end up with 48 and 2/3 plus 4 squared is 16, 3 squared is 9, and changing that to a mixed number, we would have 1 7/9. All right, we need to go ahead and evaluate our expression on the right-hand side. So I'm going to change 2/3 to 6/9. That'll help us. So we have 48 plus 1 would be 49. 6/9 plus 7/9 would be 13/9. Oops, 13/9. And let's go ahead and change that. We'll take out 1 whole, which would make 50, and taking out 9 ninths would leave us with 4 ninths here. All right, and we want to take the square root of each side. Taking the square root of this and the square root of this. So the left side is easy. We would have x plus 4/3. On the right hand side, we want to take the square root, so grab your calculator. Of 50 and 4 ninths. And we get approximately, I'm going to move over here so I have more room. I have x plus 4/3 equals, and rounding it off to the nearest hundredth, it'd be basically 7.10, so we'll leave it 7.1. And again, remember, it's plus or minus. So our two equations would be x plus 4/3 is equal to 7.1, or x plus 4/3 is equal to negative 7.1. And this is an example. We will probably want to choose to change our fraction into a mixed number, or I'm sorry, into a decimal. So as I'm going to do that as we subtract it from each side, we'll change it to 1.3. All right, and nearest hundredth, let's go ahead and add that 0. We'll make it 1.33. So we're going to subtract 1.33 from each side. We're going to subtract 1.33 from each side. All right, and solve. And I hardly saved myself enough room here. Canceling this out, you end up with x equals 5.77. And solving this other equation, you get x is equal to negative 8.43. So again, these are the two x-intercepts of the graph of this equation. Going back to our real-world problem, it asks us what is the side length x of each square plot. Negative 8.43 does not make sense for a length, so we would say to the nearest hundredth, 5.77 feet would be the length of each side to the nearest hundredth. All right, so you can see this is a rather involved and rather lengthy process. You will definitely want to be using your calculator to help you to ease some of that and make it a little bit quicker for you. And we'll do a couple of these to practice, but I won't throw anything too horrendous at you on a test. If you have any questions, please don't hesitate to ask. I would be happy to answer them. Thank you very much.